Hello and welcome to Eternity Tutorials. Today I'll be taking up continuity. In this segment, we will start with a continuous function. What is a continuous function? A function whose graph can be drawn without any breaks. Let me show you an example. I draw this graph. The graph comes out to be like this. So this is coming out without any breaks. Let me take another graph. This is another graph of a continuous function where I can draw the graph without lifting up my pen. So that is known as the continuous functions. Let me take an example. The function is equal to 1 if x is not equal to 0, and it is equal to 2 if x is equal to 0. If I draw the graph of this function, because the first part says that when x is not equal to 0, so either the x is less than 0 or x is more than 0. So this is the part I take a hollow circle because x is not included, and for equal to 1 the graph comes out to be parallel to x-axis. Now similarly for the second part, when x is equal to 0 and y is equal to 2, this is the point. If you can see, the graph has a break in between, so therefore we say that the function is discontinuous, because the graph has breaks and it is not continuous. Now every time it is not possible to check the continuity of the graph of the function with the help of the graphs, so we can take help of the limits. We all know that whenever we write the limits, we write it as limit x tending to c, where c is any constant. So now x tending to c means that it is approaching c but has not reached c. Let us see from the number line. If we have a constant c, then the numbers are approaching c either from left hand side or from right hand side. If it approaches from left hand side, that means the numbers are increasing and is approaching to c. From right hand side, the numbers are decreasing and they are approaching to c. So if it approaches from right hand side, we call it the right hand limit, and if it approaches from left hand side, we call it left hand limit. We represent the left hand limit as x tending to c negative and right hand limit as x tending to c positive. Now for a function to be continuous, the conditions required is limit x tending to c f of x is equal to f of c. This is one condition which is required for a function to be continuous. The second condition would be that x tending to c minus f of x is equal to limit x tending to c plus f of x is equal to f of c. Either of these two conditions have to be true for the function to be continuous. Let me take an example. Fx is equal to 2x plus 3. We have to check for x is equal to 1. Because we have only one function which is defined, so I take the first condition and I check for limit x tending to 1 f of x. What is f of x at x tending to 1? If you see, it is 2x plus 3. And if you put the value of x as 1 here, as you do in limits, we get the answer to be 5. What is f of 1? Again, we put the value of x as 1 and I get the value as 5. So which shows that the limit x tending to 1 f of x is equal to f of 1. So which implies that the function is continuous at x is equal to 1. Right? I'll take another example for the second condition. Function is equal to 2x plus 3 when x is less than equal to 1 and 2x minus 3 when x is greater than 1. In this example, we'll take the second condition where limit x tends to 1 minus f of x. When x is less than 1, at that time you can see from the question the function is 2x plus 3. X is less than 1, so that means we can write x as 1 minus h, where h is a very small number which takes x to be less than 1. So we write down here limit h tending to 0 twice of 1 minus h plus 3. As we put h is equal to 0, the answer you get is 5. I take the second side, that is the right hand limit x tending to 1 plus f of x, which is equal to limit x tending to 1 plus the function from the question is 2x minus 3. Now because it is more than 1, so we take now the x to be 1 plus h. So limit h tending to 0 twice of 1 plus h minus 3. You put h equal to 0 and you get your answer to be minus 1, because the limit x tending to 1 minus f of x is not equal to limit x tending to 1 plus f of x. So we say that the function is not continuous at x is equal to 1. So that's all for the basics of the continuity. In my next segment, I'll be taking up few questions related to continuity. Thank you.